And it said use, let u be x. Okay, so that means du is going to be 1/3 dx.
But then they have the x squared is 9u squared.
Is this not the one that's 1/3 inverse tan x over 3 plus c? What is? What's the derivative of inverse tan? 1 over x squared plus 1. So let's see. We know that the inverse tan, and I'm just saying this because I know that that's kind of what it looks like. All right, so the inverse tan of x, the derivative of this, is 1 over x squared plus 1. Oh, this one is tough. I've done this one. I remember doing it. They did what? I would say that is never anything that I would do. So that would become 3u plus 9, which is,
It's not 3 years.
what's the derivative of inverse tan? Is it x squared or is it x plus 1? You shouldn't have to. Why do you have to? Oh, this one doesn't have. Never mind. Never mind. I see. This is this. Then you take the 9 out. I was fixing to take the 3 out. 9u squared plus 9. This is gross, y'all. I'm going to put it out here. So I end up with d. This is actually du, right? Not yet. I just factored this 9 out from here. And instead of putting it here, I put it on the outside. And now I need to know what is dx. Well, dx, yeah, this is still dx because I haven't replaced it yet. Okay. So, and this is where it's a little bit, I taught you to, yesterday, replace dx with everything solved, or keep du here, put that in for du, and then do the opposite on the outside, right? If that doesn't make sense to you, you can always solve this one to multiply both sides by 3. So 3 du is equal to dx, and then just replace the dx with that, if that makes more sense to you. It's always made more sense to me the other way, but if that makes more sense to you, that's fine. So replace this dx up top with 3 du over u squared plus 1. Now this 3 can come out, so I have 3 over 9, which is 1/3. This one was tough. So now this is 1/3 inverse tangent of u plus c. And then, of course, I sub my u back in. X over 3. That was hard. That was hard. You don't see a lot of these problems where they give you the u and then you go from there. Most of the time you're finding the u. That makes sense. That was a lot. I'm sorry. Is 23 the same way? Yeah. We'll do 13. And what does it say to do? Verify. All right, so, well, let's find what these things are. So here, if I just did the integral of the square root of u du, I want to show that it does not equal, so I'm going to find du here. What is du? 2x, right? So the integral of f of u dx so I guess the question here, let's see, if I did, you should be able to. If u is x squared, so then this would be the square root of x squared dx, right? This would be u to the 1/2 du. So now we got our variables in terms of each other. So here, what's the antiderivative there? And what's the derivative here? If these cancel, right, that's the antiderivative. Do you agree? And now plug back in. Is that what? You don't have, because so what I did was I plugged in, what is u? Well, u is x squared. Well, the square root of x squared is just x. So what's the antiderivative of x? Right? And these plus c's are here, but that's really irrelevant right now because I'm seeing do they equal. So now, but you do have to go back and plug that u in to make sure. So u is the x squared. So 2/3 x squared to the 2/3, will that equal 1/2 x squared? And it will. Sorry. 1/2 plus 1/2 plus 1, yeah, 3/2. But you, right. So multiply by the reciprocal. And then 15, f of u equals e to the u equals 7x. So I want to show that the integral of f of u du is not equal. They're really just wanting you to see that you can't just pick any u you want and it works, if that makes sense. So this is the integral of e to the u, right? E to the u dx, so I'm going to replace that u with now I can do the antiderivative. So here, e to the u plus c. What's the antiderivative of e to the 7x? But you got to think about chain rule, right? 1 over 7 e to the 7x. U again was 7x. So, ooh, this one's a lot closer, but it still doesn't work. But you would need that. Yeah. Go back to what? Y'all done with that one? I just kept plugging in and switching things around, just substituting in. Say that one more time. With the dx, this one. Yes, yeah, yes, yes, right, yes. Because remember, whenever you go back in chain rule, whenever you go back and do the derivative, you got to get the same thing. So if I check this, well, what's the derivative of this? The 1 over 7 first, and then the derivative of e to the 7x would be e to the 7x. But you got a chain rule, so times 7, which would cause those to cancel out. So you gotta take that into account when you see that there's more than one thing in the exponent. I agree. Yes. So they just wanted you to find the antiderivative and then derive it to make sure you ended back up where you started. Yeah, you could. Yeah, yeah. Because they already gave it to you. They got that's all you do. Right, right. So what's the derivative of negative cotangent u? Right. This time it says to let u 1 minus cosine t over 2. du is going to be, what's the derivative of cosine t over u? I mean t over 2. So du is 1 half sine. Oh, this one's not as bad as the other one. It's pretty straightforward. So I have u squared, right? And now look at what I'm missing here. I'm missing, right. So I'm missing the 1/2 here. This one needs a 1/2, put a 1/2 here and put a 2 on the outside. So now y'all see that? Or you could, come here and times both sides by 2 so that it's gone. So sine of t over 2 dt is 2 du. What is the antiderivative of u squared? So I have 2/3 u cubed plus c, and then plug in your u. What was u? 1 minus cosine. I feel like Ben Stein. I say that frequently. I feel like I'm just talking monotone. Do what? Yeah, that one did make a lot more sense. All right, y'all ready to find some u's on your own? Yes, you are. I'll give you a second. X plus 2, that's exactly what I'd do. I'd let u be x plus 2 because I know what the antiderivative of secant squared is, right? And I know that the derivative of this is already there. I don't even need anything extra with it. What's the derivative of secant squared? It's just tan x, so I got tan u plus c, and then I just plug, of course, the u back in. Now you really have to understand this because we're going to do u substitution with indefinite integrals soon, and we'll have to adjust those bounds also. So I know, I'm so excited. Let's do a harder one.
So what do we need to do? Why do we need to do this?
Well, you did because you had dx in here. So if I didn't do that, I'd have secant squared u dx instead of du. So du is dx. They're the same thing. Well, to take an integral, you have to have the du. You have to have the d of the variable that's there. How about these are a lot of you may be tempted on this one to let u be sine x. But why would that not work? Because why? The derivative of sine x is not in there, and there's no way that I can make it show up in there, right? So what should I let u be? If I let u be sine x, let's just say I went, I don't know. If u is sine x, that means du is cosine x. I can't get a cosine x in there, can I? Why can't I what? Okay, so you're saying do this. Okay. So you're saying do. I'm going to change this to secant x du. I don't know yet. I haven't worked it. All right, I've got 3, and I'm pulled that out, okay? They said, what if we let u be sine x? So let's see what happens with it. I have u to the negative 2 dx. Secant is 1 over cosine. What's the problem here, though? What's my problem? Why is this an issue? What am I gonna do? Can't derive like that, right? Yeah. So I can't have the variable x in there, but I'm doing the interval with respect to it. So they all need to be x's with a dx on the end, or they all need to be a's with a dx on the end. So what can I do?
You got us. We've been told.
Start by putting what? Okay, so let me ask you this. Negative exponent means what? Let's go. Let's start over on this one. Put it on the bottom. All right, so this was 30. I'm not even going to put this 3 outside. All right, 3, we have sine x negative 2 dx. Let's try to work with the original one a little bit. Let's put it on the bottom. 3 over, agree or disagree? If you put anything over sine squared x, that's really what? Or anything over sine? 1 over sine x. Cosecant. Does this help us in any way? Is cosecant squared the derivative of any function you can think of? That's exactly right. Do you have them all memorized? Good job. This is number 30? Oh. I'm sorry. No. The derivative of negative cotangent x is cosecant squared x. Now can you do it? I set you up a little bit on that one, I'm sorry. I want you to flounder a little bit because I want you to see how you could go through a thought process and you plug it in and when you know it won't work. You see what I'm saying? Because my initial gut on something like that, if I didn't recognize, would be to let u be sine x. And what happens and why that doesn't work. But now, what does this equal? What's the antiderivative of cosecant squared? Negative 3 plus c. There, what you didn't have to use a u in that. That's when your du has a 3 in it. So has a coefficient in there or something? Yes, that's when you would do it. We didn't need it here. It is USub, but you really didn't need it. You really didn't need it here.
I'm confused on when you need the Q. I'm still confused on how it's
Okay. How is it helping us? Let's look at this one. Do you, off the top of your head, know what the antiderivative of 1 over sine squared 3x is? cosecant. Is this the same one we just did? Did we do 1 over sine squared? We made it. Okay. Dang. Okay. That's okay. But this time it's a little different. So you can make u 3x. And here, Allison, this is where I'm going to need the number, because the derivative of 3x is 3 dx, right? So I have the integral of, and I'm just going to change this to cosecant squared u. I've still got that dx there, and remember, it needs to be the same variable. So is there a way that I can write it as the same variable? Well, yes. I could say 3 dx's makes a du, right? Or 1/3, or you could just say 1/3 du is equal to dx. If you put the, no, well, you put the 3 in front of the dx, but together that makes du. So it's 1/3. I'm just kind of showing you why. U. So that's why you need U substitution. U substitution is like the backwards chain rule, essentially. Is what it's doing.
You added the 1/3.
Mm-hmm. Now I just find the antiderivative. What's the antiderivative of cosecant squared? So I got 1/3 negative tangent u plus c. So this is negative 1/3 tangent. What is u? 3x. Cotangent. Sorry. Right? Does that make sense? These are all functions. So on the last one, because I know, okay, I can pull that 3 out, right? I know what this is. I know what the antiderivative of that is.
So do you only need the u and the chain rule? Do you only need the u and the chain rule?
Pretty much, yes, yes. If you look at the equation and you've got the function and its derivative in the integral, you're going to need chain rule. I mean, you're going to need to USub. Sorry.
Are any of girls in here like